Alrighty. Starship Simulator training modules in first mission. Give this a try. Alright, bridge scanning and navigation.
Welcome to the Magellan-class Scanning and Navigation Training Module. My name is Ava. I'm the UN Space Fleet's AI voice assistant. In this module, we will review the correct procedure for identifying targets of interest, and then navigating the ship to the desired location. To begin, proceed to the ship's bridge. I have placed some waypoints on your HUD to help you find your way. Welcome to the bridge. This is the ship's nerve center, where you have command and control over any ship system. Right now we're interested in the sensors, so make your way over to that console and take a seat. This station is responsible for scanning space around the ship and highlighting any targets of interest for the command staff. Before we perform any scans, however, let's take a look at the different sensor modes available to us. The Galactic Position mode makes use of the standard UN Galactic Positioning System and simply shows us our location relative to the Milky Way galaxy. The Stellar Region mode employs the long-range sensors to detect information about star systems within a 50 light-year radius of the ship. The Star System mode uses the short-range sensors to provide a more detailed overview of the star system we are currently in, with a maximum range of about 1 light-year. Go ahead and press that button now. The range controls allow you to fine-tune the display range of the sensors, which makes it easier to focus on particular objects of interest, or to gain a high-level overview of the current star system. The central panel lists all of the valid objects in range, which you can click on to select as a target. Go ahead and click a few different targets now. You'll notice that the Target Information panel displays more detailed information about your selected target. Once you are happy with your selection, press the Send to Helm button to make the target coordinates available to the Helm console for navigation. Now head over to the Helm console and take a seat. From here, we will navigate the ship to your chosen target. Let's begin by taking a quick look at the various screens available to the helm. The left-hand display is dedicated to navigation and shows both the ship's current galactic position along with its target destination coordinates. The central display deals with the flight controls themselves, including the FTL system, sublight engines, and reaction control thrusters. The right-hand screen features the autopilot controls, toggles for the 3D target indicators, and the ship's navigation lights. Okay, let's retrieve the target information from the sensors by pressing the Use Sensor Target button on the navigation panel. Your target coordinates should now be displayed in this box, which represents your current nav target. The galactic coordinates represent the target's position in the galaxy to the nearest whole light year. The coordinates are relative to the center of our galaxy, the supermassive black hole known as Sagittarius A star. The local coordinates represent the target's position within a star system. The coordinates are relative to the system's center of gravity, which is usually a star, or the barycenter in multi-star systems. While it is possible to fly the ship manually to any location in the galaxy, let's engage the autopilot for now, so that I can take care of that for you. Go ahead and press the highlight. The ship will now automatically turn to face the current nav target, but you will need to manually engage the FTL system in order for us to get underway. You can now engage the FTL system when you are ready. While the autopilot is engaged, I will manage the ship's speed and final approach to the target coordinates, so just sit back and enjoy the ride. The FTL system works by compressing space ahead of the ship, and then expanding it behind, creating a bubble of warped space with the ship at its center. The compressed space amplifies the ship's current velocity by a factor of the FTL field strength, so the ship's sublight engines are still used to provide the required thrust. The maximum speed of the ship is therefore a combination of the FTL field strength and the thrust output of the sublight engines. For the Magellan class, this is approximately 300 light-years per hour.
6.6 light years from Earth, kitty. This is the big reveal.
Okay, it looks like we've arrived at the target coordinates. Now that we've seen what the ship can do over a relatively short distance, let's pick a target that's much further away. Head on over to the sensors console again and take a seat. This time we're going to use the long-range sensors. Go ahead and press the stellar region button to view our local stellar neighborhood. As before, you can use the display range buttons to increase or reduce the number of displayed objects, depending on your needs. If you click between a few of the objects in range, you'll notice that none of them have any detailed information yet. This is because a sensor scan is required. Let's take a closer look at our nearest neighbour. Click on Alpha Centauri, and then click the Scan Target button. You'll notice that the Target Information panel now gives us a high-level overview of the targeted system, including important data points, such as the extent of the habitable zone. This information can be used to determine if a star system is worth closer inspection. For example, if a planet exists in the habitable zone, you'll need to use the short-range sensors from within the system itself to determine if that planet can truly support life. Select one of the planets in the system that you'd like to take a closer look at, and then press center helm as we did before. Now return to the helm console and take a seat once again. Press the Use Sensor Target button again on the navigation panel to set our new nav target. Now engage the autopilot again to orient the ship to the new... And now, engage the FTL system so we can get underway. Our previous journey was merely interplanetary, but we're now leaving the Sol system behind and entering interstellar space. The Milky Way galaxy is a vast and mysterious place, where even light takes over 4 years to reach our nearest stellar neighbour. Thanks to recent breakthroughs in FTL technology, however, we can now make that same journey in around 1 minute. Even so, at our maximum speed of 300 light-years per hour, it will still take over 2 full weeks to fly from one side of the galaxy to the other. That's a distance in excess of 100,000 light-years. Our galaxy contains hundreds of billions of star systems that are waiting to be explored, in addition to countless other stellar phenomena that we don't even have names for yet. This ship and her crew are tasked with exploring distant new worlds, seeking out new life in all of its diversity, and making peaceful first contact with any intelligent species that are encountered along the way. The galaxy can also be a dangerous and unforgiving place, so as we tread cautiously into the unknown, we should remain mindful of any potential dangers lurking in the dark. We're not far from our destination now, so sit back and enjoy the view while I handle the final approach. Okay, here we are. You are now looking at an entirely new world, bathed in the light of another star. At this distance, our home is now just another point of light in the darkness of space. Does life exist here? What new things can we discover on this world? These are the questions that this ship was designed to answer. This concludes the scanning and navigation training module. You are free to continue exploring if you wish, but please be aware that your progress will not be saved. Thank you, and goodbye. Welcome to the Magellan-class Cold Start training module. My name is Ava. I'm the UN Space Fleet's AI voice assistant. In this module, we will review the correct procedure for starting up the ship's fusion reactor, and then supplying power to the vessel. The ship is currently in a cold and dark state, so for your safety, I have taken the liberty of turning on your torch for you. To begin, follow the waypoints on your HUD to the lower floor of the reactor room. As you can see, the reactor is offline, and none of the ship's systems are powered. Our first task is to provide power to the engineering decks, so let's make our way to the start capacitor's room. Follow the waypoints on your HUD to the startup distributor. As its name suggests, the startup distributor routes energy from the start capacitors to the engineering decks, and also provides the reactor with the power it needs to create the initial fusion reaction. You'll notice the device is already powered, because the start capacitors are fully charged. Let's go ahead and get some lights on by connecting all of the breakers. Start with the G-deck breakers, as indicated. And now the F-deck breakers. And finally, the reactor supply itself. Excellent. Now we can see what we're doing. You can go ahead and turn off your torch by pressing T. The reactor controls should now be online, so let's walk back to the reactor room and take a look. This console displays the reactor's vital information and provides you with full control over the reactor and its subsystems. On the left-hand side, we have the coolant section, which shows the liquid helium coolant flow and the condition of the magnetic field coils. On the right-hand side, we have the electrical section, which shows the reactor's main electrical bus, along with its input and output feeds. In the center, we have the reactor's main display, where we can control the fusion reaction itself. As you can see from all of these alarms, it would be impossible to initiate a stable fusion reaction under the current conditions, so let's fix that. The first thing we need to do is supply power to the reactor's internal bus, so go ahead and switch the reactor to startup mode by pressing the indicated button. Great. Now that the reactor has power, we can activate the vacuum pump to start purging the confinement chamber. The chamber pressure should now be dropping. To sustain a fusion reaction, we need an internal pressure of less than 10 nanopascals. While we wait for the confinement chamber to reach its target pressure, let's take care of the reactor's fuel and coolant supplies. Exit the reactor room via the door behind you, and follow the waypoints on your These storage tanks hold all of the cryogenic fluids that are used to both fuel and cool the reactor. All 4 tanks are currently empty, so our first task is to begin the filling process. Let's start with the helium component. Head behind the storage tanks to access the helium cryocooler. The cryocoolers use a process called magnetic refrigeration to convert gas into a cryogenic fluid, before pumping it into the connected storage tank. Start up the helium cryocooler now by using the indicated control on its user interface. Excellent. Now if you turn around, you'll find the helium refill valve located on the back wall. These valves control the flow of gases harvested by the ship's gas collection hardware, which is located on the underside of the forward hull. Go ahead and open the helium supply valve now to begin supplying the cryocooler with helium gas. If you turn around again and inspect the display screen connected to the helium tank, you should be able to confirm that the tank is now filling with fluid. We now need to perform the same sequence of events for the other 3 tanks. Helium-3 is the first of 2 fuels used in the fusion reaction. As before, power up the device using its user interface. And now open the helium-3 refill valve behind you to start filling its associated tank. Next, we need to start filling the 2 deuterium tanks, so let's head over to the other side of the room. Deuterium, also known as heavy hydrogen, is the second of the 2 fusion fuels. We store double the amount of deuterium compared to helium-3, because deuterium also fuels the reactor's neutral beam injectors. As before, turn on the first deuterium cryocooler. And now the first deuterium refill valve behind you. Next, turn on the second deuterium cryocooler. And now the second deuterium refill valve. Okay, perfect. All 4 storage tanks should now be filling with cryogenic fluids. For our next task, we now need to engage the cryopumps in order to start supplying the reactor with everything it needs. Make your way around to the other side of the tanks and locate the deuterium tank outflow valve. Open the deuterium outflow valve to begin supplying fluid to its connected cryopump. Next, power on the pump itself using the button indicated on its user interface. Excellent. That's half of the fuel mix taken care of. Now head over to the helium-3 tank outflow valve so we can complete the fuel supply. As before, begin by opening the helium-3 outflow valve. And now engage the helium-3 cryopump. Perfect. All we have to do now is take care of the coolant flow. Head over to the helium tank outflow valve. Now open the helium outflow valve. And finally, power on the helium cryopump. There we go. The reactor is now being supplied with all the fuel and coolant it needs. Follow the waypoints back to the reactor room, where we... To complete the coolant loop, open the helium inflow valve to start flowing coolant through the magnetic field coils. Now make your way around to the opposite side of the reactor to complete the... First, open the deuterium inflow valve. And now open the helium-3 inflow valve. Okay, great. Let's head over to the reactor controls and take a look at the coolant display. As you can see, we now have coolant flowing into the reactor. This has begun the process of cooling down the magnetic field coils, which must reach temperatures below 20 Kelvin in order to become superconductive. Okay, the temperatures look good. You can now power up the field coils. With a solid vacuum established, the field coils powered up, and fuel flowing into the reactor, you are now free to initiate the fusion reaction. Congratulations! You have now successfully started the fusion reactor. For safety, the reactor automatically starts up at only 10% of its rated power. This means high voltage systems, such as the FTL drive, will be underpowered until you increase the reactor output. Let's resolve that now. Increase the power level to 100% using the indicated controls. You'll notice that you can increase the power beyond 100%, but doing so for an extended period will overheat the reactor, causing damage and forcing an uncontrolled shutdown. Okay, we now need to provide power to the rest of the ship. With the reactor now powering itself, you can go ahead and switch the internal bus mode from startup to supply. Perfect. If we now head around to the opposite side of the reactor output distributor should now be powered up. This device distributes the reactor's output to the ship's high voltage systems, which are in fact the only systems powered directly by the reactor. The rest of the ship is powered by 48 individual battery arrays, which we now need to begin charging using the reactor's output. Go ahead and connect all 5 of the output breakers here. Excellent. If you turn to your left, you'll see the 5 high voltage distributors are now coming online. Head over to the main battery distributor. This device takes the high voltage reactor feed and distributes it to each of the 8 battery rooms on F-deck. Go ahead and connect all 8 output breakers. Perfect. The battery arrays should now be charging. but we should perform a visual inspection to make sure. Follow the waypoints on your HUD to port battery room 1. The electrical supply on Magellan-class starships is divided into 4 isolated quadrants: forward, aft, port, and starboard. For increased redundancy, each quadrant is powered by 2 physically isolated battery rooms just like this one. Should the battery arrays in one room cease to function for any reason, the arrays in the second room will continue providing power to that particular quadrant. Similarly, power to one quadrant can be lost entirely, without impacting the supply to the remaining 3 quadrants. Okay, let's take a look at one of the individual battery arrays. On the left-hand side of the user interface, you have controls for managing the input and output breakers. And in the center, you have controls and information relating to this array's 10 solid-state battery cells. If we did everything correctly, all of the cells should now be slowly charging up. For the next step, we now need to connect each of the 8 battery rooms to the ship's electrical grid. This task will take us into the ship's labyrinth of maintenance tunnels, so be sure to watch your head. Follow the waypoints on your HUD to port battery aggregator 1. Each battery room has a corresponding battery aggregator, just like this one. These devices perform load balancing, and also combine each room's 6 individual battery arrays into a single high-voltage lead. Go ahead and connect the output breaker now. Okay, 1 down and 7 more to go. Next, head over to port battery aggregator. As before, connect this aggregator's output breaker. That takes care of the port battery rooms. Let's make our way... Go ahead and connect the output breaker. And the same again on forward battery aggregator 2. Okay, onwards to the starboard quadrant. Same again, connect the output and the second starboard aggregator. Almost done. Just the aft quadrant to go. Connect up the first, and finally the second aft aggregator. Okay, perfect. All 48 of the ship's battery arrays are now connected to the electrical grid. All we have to do now is supply power to the ship's remaining decks, and then perform a few cleanup tasks. We can do most of that from the reactor room, so let's head there now. Follow the waypoints on your HUD to the forward deck distributor. Each deck in a given quadrant is fed by a deck distributor, which takes the total electrical load of that quadrant, and then load balances it between the two connected battery aggregators. Go ahead and connect the output breakers for all 7 decks in this quadrant. Okay, now head over to the starboard deck distributor and do the same. And now the aft deck distributor. And finally, the port deck distributor. Perfect. All quadrants on every deck now have power available from the ship's main battery arrays. You'll notice, however, that the ship is still under emergency lighting conditions. because F and G decks are still using the start capacitor's supply. To resolve this, we simply have to switch the 4-quadrant distributors on F and G decks over to the main battery feed. Head over to the G deck forward quadrant distributor. Each deck has 4 of these devices, one for each quadrant. They are fed by the corresponding deck distributor. Go ahead and switch this quadrant over to the main. That's better. Now we can really see what we're doing. Now head over to the starboard quadrant distributor and do the same. And now the aft quadrant distributor. And finally, the port quadrant distributor. That's G deck taken care of. Let's do the same for F deck. Head upstairs to the F deck forward quadrant distributor. As before, and now the same on the starboard quadrant distributor. And again on the aft quadrant distributor. And finally, the port quadrant distributor. Well done. That's the main objectives of the cold start procedure complete. But we have one final bonus task to perform. Follow the waypoints on your HUD up to the bridge, and we'll make the ship flight ready. The lights and bridge systems are still turned off, so let's bring everything online. Head over to the A deck distributor in the engineering alcove. Now go ahead and turn on the bridge lighting. And now power up the bridge systems. Okay, there we go. You have successfully started the fusion reactor, routed power to all of the ship's decks, and brought the bridge online into a flight-ready state. This concludes the Magellan-class Cold Start training module. Good luck, and I hope you'll join me again in future training modules.